Agentic AI. I mean, you've heard this term everywhere, right? It's one of the biggest buzzwords in tech, promising this future of autonomous, self-directed systems. But, how much of that is just hype, and what's the actual reality for the teams on the ground building this stuff? So in this explainer, we're going to strip away all those marketing labels and get to the technical core of what these systems really are.
Okay, so here's the plan. First, we're going to tackle the myth of autonomous AI. Then we'll get into the weeds and look at the simple control loop that's actually powering these systems. From there, we'll explore how that loop can seriously amplify risk, what it really means for the human workload, and finally, we'll wrap up with the essential rules for designing safe and responsible automation.
All right, so first, let's talk about the language we use. It might seem like a small thing, but the words we choose, the labels we stick on this tech, they directly shape how we think about it. And when those mental models are wrong, well, the systems we build can get really dangerous really fast.
I mean, you've seen these words pop up all over the place. They're used to describe systems that can supposedly think and act all on their own. It kind of paints this picture of, I don't know, a digital coworker, an independent agent making its own choices.
But here's the thing, and this is so important. Those descriptions, they're just flat out misleading. They set up completely wrong expectations and can trick us into building systems that are unsafe precisely because we don't understand what they actually are. Okay, so if they aren't these autonomous thinkers, what in the world are they? This next part really gets to the heart of it. Let's pull back the curtain and see what's really going on under the hood.
And this, right here, this is the reality. An agentic system isn't really an agent. It's a system. And at its core, you've just got this simple control loop that executes logic that we, the humans, have defined. It's not thinking, it's just processing.
So how does this loop actually work? Well, it's a pretty simple four-step process. Step 1, it observes its current state. Step 2, based on that state, it generates some kind of output. Step 3, it uses tools, like APIs or other software, to act on that output. And step 4, well, it just does it all over again, and again, and again.
This is where it gets really interesting, right? You've got this stark contrast. We imagine these systems have some kind of intent, but really, they're just executing logic. We think they have some kind of judgment, but nope, they're just following rules that we wrote. And we assume they understand outcomes, when in reality, their entire world is defined by us.
So why do they seem so smart then? It's kind of like watching one of those crazy, complex Rube Goldberg machines. Each individual step is super simple and mechanical, but when you chain hundreds or thousands of them together, the final results can look surprisingly clever. It's that whole chain of events that creates this powerful illusion of reasoning. There's no actual thought happening here.
Look, this difference between a loop and a real mind, it's not just some academic debate. It's absolutely critical. Because the very thing that makes them seem so intelligent, that repetitive loop, is also what makes these systems uniquely dangerous. So let's dig into how that simple little loop can actually blow up risks in a big way.
Just think about it for a second. What happens if the system makes one tiny mistake in one cycle of that loop? That error becomes part of the new state that gets fed right back into the next cycle. The loop doesn't fix it, it actually amplifies it. This is a really key idea right here. You see, the system's memory, its state, it isn't a clean slate. It carries every single mistake forward. An error made in step 1 can poison the results of step 10 or step 100. The mistake gets baked right into the system's history.
And this is where things get really scary. The second you give that system access to real tools, the power to send an email, change a database, or call an outside API, you're massively expanding its blast radius. Suddenly, a small, amplified error isn't just a bug in a log file anymore. It could be 1,000 wrong invoices sent to customers or a critical production database getting totally corrupted.
Okay, so that brings us to the human side of all this. There's this popular idea that these systems will just make our jobs easier, reduce our workload. But the reality is way more complicated. It's not really about less work. It's about a fundamental shift in what our work even is.
So, yeah, the myth is you can just, set it and forget it. But the reality? Oh, man. Your workload totally shifts from actually doing the task to this high-stakes job of just monitoring a system that could fail spectacularly at any moment, and then having to clean up the mess when it does. That's a very different and way more stressful job.
Here's another big myth. That autonomy is just some switch you flip on at the very end. But authority doesn't transfer all at once. No, it trickles away.
It shifts little by little every single time a human starts to trust and rely on what the system is telling them. The moment you stop double-checking its work, you've just handed over a piece of your authority.
Okay, so knowing all of that, how do we even begin to build these things responsibly? Well, it's not about stopping experimentation, not at all. The key is designing for safety right from the get-go by putting in some essential guardrails. And here they are. These are the 4 non-negotiables for doing this safely. First up, explicit stop conditions. Think of it like a big red emergency stop button so the loop can't just run wild. Second, bounded permissions. This just means the system only has the keys it absolutely needs and nothing more. Third, meticulous evidence logging. You need an audit trail so you can always figure out what did it do and why. And finally, and this one is so important, you need pre-planned rollback paths to quickly undo the damage when, not if, things go wrong. And let me be super clear here. These are not nice-to-haves. Without these controls in place, those small errors we talked about will spread through your systems faster than you can imagine. These are your emergency brakes. You absolutely need them.
And I want to be really, really precise about the point of all this. What we're doing here is explaining the system's behavior so we can all design more responsibly. We are absolutely not trying to discourage experimentation. But, and this is a big but, this analysis is not a green light to just deploy these systems into production.
So let's wrap this up. If you take away just one thing, let it be this. Agentic systems are not intelligent actors. They don't think, they don't reason, they have no intent.
What they are incredibly powerful automation constructs. They're tools. Very sophisticated tools for sure, but they're still just tools. And just like any powerful tool, we've got to treat them with a healthy dose of respect and caution.
So I'm going to leave you with this one question to take back to your team. Look at what you're building and ask yourselves honestly, are you designing for the myth of an intelligent actor, or are you engineering for the reality of a powerful automation construct? The safety and the success of your project really hangs on that answer.